Hello, linear momentum. If you have not seen this before, you have studied physics, or you have seen it before, you have read it before, you find it difficult to understand, this lecture will assist you. Don't run away. I'm going to break everything down. So in this class, we are going to define Newton's laws of motion, because that's what you need to understand momentum. After that, we look at force, impulse, and momentum itself. Then we look at the formula you need to do calculation that involve momentum. Then we look at a lot of calculations. The topic is very wide, but I'm going to assist you to make you understand it. So please don't run away. So the first thing we need to do now is to define Newton's laws of motion. Say for instance, this is a table. Okay? Say this is a table. And there is an object on this table. Newton is saying that this object will remain here forever. This body, object, in physics we call objects bodies. Anything is body. Even me, I'm a body. This pen is a body. This board is a body. The earth is a body. You are a body. So this body on top of this table, Newton is saying it will remain here forever unless you apply a force. He also said that this is a ball now. This ball is flying or moving in a uniform velocity, in a uniform motion. It will continue to move forever except external force is applied to stop it. If you don't apply external force, maybe another player stop it with head or with leg or with chest, the ball will continue to fly. But the point is that why is it that if you shoot a ball now without anybody stopping it, it will still come down? Because there is force of gravity. The gravitational force is pulling it down. If that force is not there, like if you are in outer space, all those astronauts, when they are in outer space, there is no force that is applied on them, no gravitational force. They can remain in a position forever, or they can be flying without anything dragging them down. That is what Newton's first law is explaining. So this is the definition. It says that what? Everybody continue in state of rest. Okay? Or uniform motion in a straight line. In a straight line. Unless it is compelled by some external force to act otherwise. You were going like this, a force, you are now coming down. You are going like this, a force, you are coming like this. You are going like this, another force, you are going further. It is external force that will cause it to act otherwise. Okay? That is what the Newton's first law of motion is talking about. For the second law of motion says that the rate of change of momentum. The rate of change. What is momentum? Momentum is actually when you multiply mass of a body, the mass, and the velocity. For you to get velocity, this is a body, for instance, say it's a ball. It's a ball. It has a mass m. This body, for it to move, you need to apply a force. It's the movement that is bringing this velocity. And this velocity cannot come if a force is not applied on the body. So this is saying that this is actually momentum, right? That is mv or mu, initial velocity. He's saying that what the change of this momentum, if the momentum is going to change, okay, the rate of change of the momentum of this body is proportional to the applied force, the force you applied to cause it to change, to cause this change in momentum. Because look at it, this is a body, this is mass. As you apply a force, you are bringing in v or u. Say you bring u, initial velocity. Now, this initial velocity is, there is no change in momentum now because mv or mu is momentum. mv or mu. Only m is not momentum. Only u is not momentum. Only v is not momentum. mu or mv. It has mu. Initial velocity, say it is 10 meters per second. that this body is experiencing, moving. If you want to change the momentum, it means you have to apply a force. What is the meaning of that change now? To increase this velocity, because this mass cannot be increased. The mass of the body will remain the same. You can only change this what? Velocity. So if you change this velocity to 20 meters per second, that means there is now a change. So this one now is now mv. There is a movement from here to here. This has changed to this. The change of this is mv minus mu. What it was before minus what it is now. Momentum. Is saying that what? The rate of change of this momentum, this is the change now. The rate of change, whenever you hear the word rate, we are talking about the time. The rate of change of momentum of a body is proportional to the applied force and take place in the direction in which the force acts. Because if I was moving like this, my change in direction depends on where you apply the force. If you hit me here, I will move like this. If you hit me here, I will move like this. If you hit me here, I will continue to move like this. Okay? So that is what it is talking about. Newton's laws of motion, right? The second law of motion says that what? The rate of change of momentum of a body is proportional to the applied force and takes place in the direction in which the force acts. It's a normal thing now. It's a normal thing. That if something is moving like this, you put more energy. It's like a footballer now. You kick a ball, another person head it. It depends on where you head it to now. That is the direction now. The force you apply will determine the direction of what? Of the momentum. So the rate of change of momentum is proportional to the force. And it moves in the direction of the first what you applied. That's what we are talking about. That is Newton's second law of motion. Okay? The third law, which is very common. The third law of motion states that whenever a force acts on a body, that is on one body, an equal and opposite force acts on some other body. This is a man. Another man. Give this man a dirty slap. That slap is coming from this hand. A force is applied from this palm on this face. The face itself will also apply a force on the palm. Action, reaction. A football, you kick the ball, boom. You kick the ball. As you kick the ball with your leg, the leg has applied a force on the ball. The ball itself will also apply a force on your leg. To every action, there is equal and opposite reaction. That is Newton's third law of motion. Okay? In other words, to every action, there's equal and opposite reaction. Now I believe you understand the three Newton laws of motion. You know how to define them. You understand them. Next now is to go for force, impulse, and momentum. Okay? Now, let's go for this. Force, impulse, and momentum. What you should know is that momentum, then tum, is equal to the mass of a body multiplied by velocity. Okay? We are talking about a moving body. This is the mass, the matter, the atom that make up the body. Is it moving? Yes, it has V. It has matter, it has matter. When you join the two together, multiply. That is what? Momentum. The unit of momentum, as you can see here, this is kg. This is meter per seconds. Which if you join together, you're going to have kg meter per seconds. Which you can also write as kg meter per seconds. Like this. You can also put it as Newton seconds. I'm going to tell you why we say it is Newton seconds. Okay? So now, if you are asked, this is the SI unit, you can also use NS as the unit of what? Momentum. Say this is a body, for instance. This is a body. Okay? This body, let's say it has mass, it also have initial velocity u. Okay? As it was moving, a force was applied. The force bring a change of velocity, which amount to change of momentum. That moved this u to v. So the initial momentum that it was experiencing, the initial, is equals to mu. Why the final? Is mv. Okay? All this is just u has changed to v because there was a force that moved it from 10 meters per second to 100 meters per second, for instance. Okay? So we are saying the change of momentum now. You agree with me? The change of momentum is equals to the final minus the initial. Of course, what you are now with what you were before. What you are now minus what you were. You can know your changes. If you are going positive in life or negative in life. How much in your bank now? 100k. How much was it last year? 200. Minus, that is minus 100. You are going backward. So the change is where you are, the current momentum, minus where you were. Okay? Now we are saying the rate of change. Whenever you see this word rate of change in momentum, whenever you see this rate of change, we are bringing in time. Remember, this is change of momentum. We already have change of momentum. Or change in momentum. Any way you want to call it, change in momentum. That is, change in momentum. You are bringing in time. That is to say, this now is equals to mv minus mu over time. Okay? That is the rate of change in momentum. You are bringing in time. The changes, we want to look at the time. Not just you are changing. How long, how fast, how quick, how slow. Okay? If we go back to look at Newton's second law of motion, it says what? The rate of change of momentum, the rate of change of momentum, mv minus mu over t, is what? Is proportional to what? To the force you applied. Okay? The rate of change of momentum is proportional to the force applied. So you can say this now is proportional to m is common, then v minus u over time. Okay? I want to ask you, what is this to you? Rate of change of velocity. What is that? Acceleration. It means F, therefore, is proportional to this mass, then this acceleration. Okay? That is why you see that we write F as equals to ma. So this now takes us to what? Impulse. Impulse. Let's look at impulse. What is impulse? In this lecture, we have done momentum. What is impulse? Impulse is force multiplied by time. I give you blow. How long? This is a force. But how long did this stay on your cheek? The time. F multiplied by t, which is ft. So the product of force and time. That is how long does this force remain on the body. That is called what? Impulse. If you have been following me, we have established that force is equals to m v minus u over time. If I do ft here now, you agree with me, and I have this. What do you call this? This is called what? Change in momentum. Change in momentum. It means that this ft is equal to change in momentum. What is ft? Ft is impulse. So impulse is also equals to change in momentum. So that is the reason in the beginning of this lecture I told us that what? You can also measure change in momentum either as kg meter per seconds, which you can also rewrite as kg meter this. They are the same, right? Or because this one is talking about this side, m for kg, velocity for this. But we can also use this side of this formula because change in momentum is equal to ft, which is what? Impulse. We can also use this one as ns because this is n, time is x. So either of them are the unit of what? Change in momentum. Okay, change in momentum. Hope you understand the way we are tackling this. Because you need this knowledge to solve questions easily. Okay? So in summary, you can say that what impulse is equal to ft. What is f? F is ma. Right? F is equal to ma. So we can bring ma to replace this times t, which is what? Mass times acceleration times time. So you can see all of them are just related. If you know what is velocity, you apply it here. If you know what is acceleration, you apply it here. You are just moving around because you have to be what? Dynamic when you are solving questions. Don't say, oh, they taught me momentum. I don't want to know what is force. No, you have to bring in force. If you can bring in force, you have to bring in velocity. You have to bring in acceleration. It depends on what you are seeing before you. Okay? Okay? Hope you are hearing me. Don't forget. So the next thing we are going to do now, according to our lecture plan, to go for calculations. Calculation. Let's look at this question. It says, a body of mass 2 kg moving vertically upwards has its velocity increased uniformly from 10 meters per second squared to 30 meters per second squared in 4 seconds. Okay? Neglecting air resistance, calculate the upwards vertical force acting on the body. Mass is given to be 2 kg. The initial velocity is given to be 10 meters per second. This is given to be 30 meters per second. The time is given to be 4 seconds. We are asked to calculate F. F is m v minus u over t, which is equals to, what is m? M is 2, v is 30, this is 10 over t, which is 4. So therefore, this is 20 multiplied by 2. You agree with me? 4 here 1, 4 here is 5. If you multiply this, it's going to have 10. That is F now is 10 Newton. 10 Newton. Hey, do you know how to calculate impulse? If you don't know, let's see. A ball of mass 0.15 kg is kicked against a rigid vertical wall with a horizontal velocity of 50 meters per second. Okay? If it rebounded with a horizontal velocity of 30 meters per second, calculate the impulse of the ball on the wall. Impulse, remember F is equals to m v minus u over t. Ft is equals to m v minus u. This Ft is referred to as what? Impulse. Force times time. The time the force used to act multiplied by the force. That is how to get the impulse. It's also equal to change in momentum. This is change in momentum. Mass times change in velocity. So as you can see from this now, we know the mass to be 0.15. The final velocity that was given to us, because this is the final, it is a rebounded velocity. When something is moving like this, it returns. This is the initial direction, opposite. It becomes negative. It means the final velocity is minus 30. Then we put this minus, the initial is 50. So, it's like we are saying there are many ways of going to a location. You can pass here, you can pass here. These are the two ways. Either you go through FT or you go through this md minus u. You are still calculating what? The impulse. So therefore, you agree with me, this minus 80. You're going to get minus 12 kg, because this is kg. This is what? Meter per seconds. You can also say it's minus 12 ns, that is Newton seconds, either of them, okay? Because these are the two units of impulse. This is the SI unit, this is the derived unit. So therefore, the magnitude is 12 Newton seconds, or 12 kg per meter square, but the direction is minus, opposite. Look at this question. Do you know how to calculate momentum? If you don't know, this is for you. A force of 100 Newton is used to kick a football of mass 0 kg. Find the velocity with which the ball moves if it takes 0.8 seconds to be kicked. Why did I talk about momentum? Because this whole description is all about momentum impulse. Although we are asked to calculate the velocity, it means F, which is this, is what we are going to use. The force is given to us as 100. The mass is given to us as 0.8. So what is the final velocity? We don't know. We are asked to find the final velocity. The initial velocity is 0. Why are you putting 0? Because it was at rest. A ball needs to be at rest before you kick it. At rest, it means u is equal to 0, initial velocity. Then over time, 0.8. Now we can find t. 0.88, 0.88. This and this will cancel. V is equal to 100 without wasting our time in meter per seconds. Let's look at this. Don't go away. Look at this. A 0.05 kg bullet traveling 500 meters per seconds, traveling horizontal, okay? Strike a vertical wall. It stops after penetrating through the wall a horizontal distance of 0.25 meters. If this is the wall, this bullet you are seeing here traveled to this extent, east side, pass it through here, went here, and later stopped. So this distance it covered here is this, the distance inside the wall. Okay? What is the magnitude of the average force the wall exerted on the bullet? Remember, to every action, there's equal and opposite reaction. When you exert your force on the wall, Mr. Bullet, the wall also exerted a force on you. What is that? What? Force. The force that will be exerted can be calculated as MA, because to every action, there's equal and opposite reaction. This mass and acceleration, that is a moving force. Moving force. So whatever that is going to stop this moving force is equal to the moving force. Action you are moving, it needs, that is the wall needs the same amount of force to stop you. You are producing this force with MA. For the wall to stop you, it still needs the equal amount of force that this MA is producing. So to get what this wall is using to stop the bullet, we must use MA. Give and take. I stop you with the same amount of force. We know M. We don't know A. But we know the distance it went. We know this as initial velocity. The final velocity, finally, it will stop. It means 0. Because it's coming to a rest, the bullet. It means, therefore, we can use the formula that says this, u squared plus 2as. With this, I can get A, because I'm looking for A to get this force. I know M already, so I need A. So to get A here, you agree with me, is this minus this, over 2s to get A. You make A the subject of formula. I don't need to explain that. So what is V? V is the final velocity, 0. Initial is 500 over 2s. 2 multiplied by s, 2 multiplied by the distance. S is the distance, that is 0.25 to get A. It means A therefore is 500 times 500 over, if you multiply this now, you agree with me, you're going to have 0.5. Okay? You agree with me that if I move this here now, we'll put extra 0. Okay? It means therefore, I'm going to have 25, 1, 2, 1, 2, 3 over 5. Okay? 5 here 1, 5 here 5. It means if we include zeros, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is my acceleration, meter per second square. Very high acceleration. The bullet was coming very fast. So I need to multiply this by the mass to get the force that this bullet has. The force, the total force it was coming with is ma, which is, and the mass is 0.05. 0.05 multiplied by this what? 50,000 or 500,000. 500,000 acceleration. So this 1, 2, 2, 0 will go out of this place, becomes 5 times 5, 1, 2, 3. Okay? That is 25, 1, 2, 3 in Newton. So this is the force at which the bullet was coming. This wall, the wall also needs the same equal force to be able to stop the bullet. Otherwise, the bullet will penetrate. Okay? Hope you understand the explanation. Let's look at this question. It says a net force of magnitude 0.6. The force is equal to 0.6 Newton. Has on a body of mass 40 grams. So the mass of the body is equal to 40 grams. And this is not the SI unit of force. The SI unit of force is kg. It means nobody should tell you to convert this to kg. To convert this to kg, what do? You simply divide this by kg, which is still m is equal to 40 over 1,000. This and this will cancel. It means you're going to get 0.04 kg for our mass. Don't use it like this because this is not what? The SI unit. It says it was initially at rest. From our definition, if you have been following me, from our definition, everybody will remain at rest. Calculate the magnitude of the force resulting acceleration. If you apply this force on this body, what will be the resulting acceleration? Now you had force, you had mass, you had acceleration. What connects this together? It is a formula that is F equals to ma. What mass? Mass is 0.04 multiplied by A. A is what? Is what we are looking for. What is force? 0.6. Now we make A the subject of formula to have 0.6 over 0.04. Okay? It means therefore this and this will come here to have this come here extra 0. That is 60 over 4. So A therefore is 15 in meter per second square because that is the unit of acceleration. So this is the answer for this question. Let's look at this. It says a truck of mass this. Say this is a truck. Huh? So this is the truck. Big truck. The mass of this truck is 3,200 kg. Moving with a velocity of 10 meters per second. increases its velocity to this. That means before now, it has initial velocity of 10 meters per second. You don't need to be told there was a velocity, there's another velocity. It means it was somewhere before, it's now in another place. That is initial, final. So the final is 20 meters per second. Okay? How long? 5 seconds. 5 seconds. No problem. Calculate the magnitude of the force exerted on the engine. Because force is now involved, force is equals to mv minus u over t. What is m? M is 3200. What is v? That is 20. U 10. Okay? All over time 5. Which is equals to 3200 multiplied by, this is what? 10 over 5. Okay? 5 here 1, 5 here 2. If you multiply this, you're going to have 6400. In Newton. So this is the force that was applied on the engine. Okay? The force that was applied on the engine. Let's look at this. Okay? A body of mass 20 kg is set in motion by two forces, 3 Newton and 4 Newton, acting at right angle to each other. It means, therefore, that to achieve right angle, it means the angle between the two forces is 90 degrees. So here is 90. So this is the first force, 3 Newton. And this one is 4 Newton. You get it? Now, they are acting at 90 degrees to each other, and this is the body. So this is the body. This body is 20 kg. And this force are being applied on it. And the forces are perpendicular to each other. Okay? Determine the magnitude of its acceleration. How fast is the body when you apply this force on it? You are dragging. How fast can you drag it on this 20 kg? So what we normally do, we find the resultant force that is at the center. So we can transfer this here now. That is, we transfer it here because this and this are parallel. Okay? So we can say here is 3 Newton. This line, as you can see already, is what? Is 4 Newton. We can now call this one R, the resultant force. We can apply the Pythagoras theorem. So it means, therefore, R is equal to the square root of 4 square plus 3 square, which is 16 plus 9, which is the square root of 25, which is equal to 5 Newton. So this is the resultant force that is being exerted on this 20 kg. You are applying 3. Another person is applied 4. What will this body feel? The effect on the body, the resultant is 5 Newton. Okay? Now that we know this, it's asking us to determine the magnitude of its acceleration. Magnitude of acceleration? Okay, we have this mass. The mass is known. We know this now. This resultant is also F. That is the resultant force. So can I say F is known to be 5 Newton? Okay, so we are asking for what? Acceleration. Wow, that is F equals to ma. A here is F over m. What is F? F is 5. What is mass? Is 20. If you divide this, what are you going to get? 5 here 1, 5 here 4. That is 1 over 4. That is 0.25 in meter per second square. So this is the acceleration where you exert these two forces on it. Okay? You exert these two forces on it. Let's look at this. It said a moving car of mass 800 kg experiences a frictional force of 200 Newton. If it accelerates at 20 meters per second square, calculate the magnitude of the force applied on the car. You agree with me, for a car to move there is a force from the edge on the body that makes it move. Why this force is coming from the edge that's making the car to move? It's experiencing opposition. It means the applied force minus the opposition will give us the net force. The net force. So, this is the net force is equals to the applied force. The force you applied minus the friction. The frictional force. Okay? So the applied force, the frictional force, if you remove this from the applied force that is coming from the engine, it is the remaining one that will be used to move the body. This is the net. You apply a force from the engine, there's opposition. You have to remove the opposition. It is the remaining one, the remaining force that the body, the car will use to move. The question is saying we should calculate what? The magnitude of the force applied, this one. It means the force applied is equals to, bring this here, that is the net plus the frictional force. Okay? So now, what is this net? The net. How can you locate the net? You apply a force from the engine. You remove friction. The remaining one is the net force. What is that? How to know is the body moving? Yes. That body that is moving, for it to move is MA. It is the net force that is causing the MA, mass times acceleration. So it means therefore, this is what? Mass times acceleration plus the frictional force. Okay, so therefore, if you check now, you find out you have 800 multiplied by the acceleration 20 plus this 200. Okay, that is, this will give us 16,200 in Newton. Okay, so this is the total force that is needed to cause this body to accelerate at this rate. Because this engine has to provide a force to neutralize this 200, the remaining one to cause it to move. Okay? Look at this. It says a rope is being used to pull a mass of 10 kg. So this is the mass, is 10 kg. A rope is being used. Say this rope, let's say somebody is here holding this rope, pulling it up. Say it apply a force F to take it upwards. Remember that this mass now, it has weight, and this weight is mg. Mass times what? Acceleration due to gravity. But the tension here is in this direction. The force is in this direction. The only thing that is opposing them is the weight, because it is going up. The tension is on the rope. This is the force that is actually taking it up. You apply by yourself, taking it up. The tension on the rope is going up, but the weight of the body is going down. So determine the tension in the rope. If starting from rest, the mass acquires a velocity of 4 meters per second in 8 seconds. Starting from rest means u is equal to 0 meters per second. It means this other one is final velocity 4 meters per second. Time is 8 seconds. It means they are giving us this over t, okay? So, we know the mass to be 10. We know final velocity to be 4. Initial is 0. And time is t. You agree with me? The t here is 8, okay? So, you agree with me now? We have 10 multiplied by 4 over 8. 4 here 1, 4 here 2, 2 here 1, 2 here 5. It means therefore we have 5 Newton as what? The force. Okay? The force applied. Now, the question is, how do you connect this? Because we are looking for the tension. As you can see, the tension T on the rope and the force we are using to pull it upwards, two of them are in the same direction. So we cannot say T plus F equals to width. Okay? So two of them are going upwards. This is opposite. They are equal. Therefore, to get the tension, we say W minus F. What is W? W is mg. That is the mass, which is 10, multiplied by G. G, generally, we take it as what? 10 minus F, which is 5. You get it? This W is this, mg. Okay? So therefore, we have 100 minus 5, which is this. So finally, T is equals to 95 Newton. Okay? 95 Newton. You must understand the flow of the force. You are pulling it, going upwards. The tension on the rope is also up. The weight is coming down. The weight is mg. The force is this. Very easy. Let's look at this. A ball of mass 0.5 kg hits a smooth vertical wall, normally with a speed of 2 meters per second. Okay? And it bounces with the same speed. Determine the impulse experienced by the ball. The impulse experienced by the ball. Let's start. The mass is 0.5 kg. The speed, which is initial speed now, because it's moving at that speed. But when it hit the wall at a bound, at the same speed, that is the final velocity now. But you agree with me, it was going like this, rebound, opposite direction. It means the final velocity is minus 2 meters per second. Because we are told the same speed, but rebounds opposite. That is the minus. Okay? It means that Ft, which is also impulse, is mv minus u. Okay? It means with this alone, we can get this impulse, because impulse is actually equals to Ft. You can use Ft to get it. You can use this to get it. This is the information we have. We use the information to calculate it. That is 0.5. The final is minus 2 minus this 2, which is 0.5 minus 4, which is minus 2.0 in Newton seconds. In Newton seconds. But the next thing you are asking me now, this negative value, we are looking at the magnitude, not the direction. So you can easily write here that what? The magnitude is equals to, that is the magnitude of the impulse is equals to 2 Newton seconds. Why the direction is the opposite to the initial direction. The negative value is telling us about the direction, while the 2 is telling us about the magnitude. Okay?